So, we have done that minimum fluidization velocity, and what is the expression to find out the delta P or pressure drop from the minimum fluidized based condition, right, using Ergun's equation. This we have done. Now, let us do some problem for that. Number 1, say a problem is like this: a solid particle having a size of 0.127 millimeter, a shape factor of phi s of 0.9 and a density of 1100 kg per meter cube are to be fluidized using air at 2 atmosphere absolute and 30 degrees centigrade. The voidage at minimum fluidizing conditions is 0.4. The cross section of the empty bed is 0.3 meter square and the bed contains 300 kg of solid. So, calculate number 1, the minimum height of the fluidized bed. Number 2, the pressure drop at minimum fluidizing conditions. Number 3, the maximum velocity for fluidization. Given viscosity of the fluid is 1.8 10 to the minus 5 Pascal second and molecular weight of the medium is 29. That is the fluid having molecular weight of 29, of course, kg per kg mole, right. So, if we reread, if we read once again, it looks like this: the problem, a solid particles having size of 0.127 millimeter, shape factor of phi s of 0.9, density of 1100 kg per meter cube are to be fluidized using air at 2 atmosphere absolute and 30 degree centigrade. The voidage at minimum fluidizing conditions is 0.4. The cross section of the empty bed is 0.3 meter square and the bed contains 300 kg of solid. Calculate number 1, the minimum height of the fluidized bed. Number 2, the pressure drop at minimum fluidizing conditions. Number 3, the maximum velocity for fluidization. Given viscosity of the fluid 1.8 10 to the minus 5 Pascal second, molecular weight 29 kg per kg mole, right. So, if we solve it, it looks like this, that given from the conditions given are particle having size or dP is equals to 0.127, right, millimeter, shape factor phi s is equals to 0.9, density rho is equals to rho particles is equals to 1100 kg per meter cube, pressure P1 or inlet is equals to 2 atmosphere absolute or is equals to 2 into 1.01325 10 to the power 5 Pascal. Then temperature T is equals to 30 degrees centigrade. Then epsilon is equals to epsilon mf is equals to 0.4. Cross sectional area is equals to 0.3 meter square, and bed contains 300 kg of solid, that is W or M, whatever we call, M is equals to 300 kg solid, right. Apart from that, we are also given mu of the air, that is fluid, is equals to 1.8 10 to the power minus 5 Pascal second, and molecular weight of air is equals to 29 kg per kg mole, right. This is what we have been given, right. Now, for solving it, let us take this way, that if epsilon would have been 0, that is there is no void. Earlier also we have done the same thing, that we can use the mass, density, area of the bed to obtain the height of the bed in complete packed bed condition, right. So, if epsilon would have been 0, then we can write L 0 A 0 into 1 minus epsilon 0. This is equals to L M F A 0 into 1 minus epsilon M F, because we said uniform cross section earlier also, that there is no change in the cross sectional area, because as long as this is fixed, our sectional area also remains same, right. So, if that be true, we can say that LMF is equals to L 0 A 0 by A 0 into 1 minus epsilon MF, if epsilon 0 is 0, right. We have taken that epsilon 0 is 0, right. So, if that be true, then we can write this is nothing but L 0 by 1 minus epsilon M f, right. Now, volume of the solid this is equals to, we have been given that mass is 300 kg of solid by the density rho of the solid, which is given 1100, right, 1100 kg per meter cube, right. So, this means 300 by 1100 meter cube, right. And yes, let us look into how much it comes, 300 1100. Let us take that calculator. Point 2727 is equal to 0.2727 meter cube, right. So, if volume of this is so much, then L 0 that will be equals to volume of the solid divided by cross sectional area, right. So, this is equals to volume has become 0.2727, right, divided by 1100, divided by cross sectional area. Cross sectional area has been given 0.3. So, this we can write that 0.2727, if we take this way, 0.2727 divided by 0.3 is equal to 0.909. So, 0.909 meter is L0. Therefore, LMF, this now becomes equal to L0 by 1 minus epsilon MF, right, and 1 minus epsilon MF, L0 is 0.909, 1 minus epsilon MF is given 0.4, right, is equals to 0.909 divided by 1 minus 0.4, that is 0.6. So, 1.515. So, minimum fluidized bed height, height of the bed under minimum fluidized bed condition, minimum fluidization condition is 1.515 meter, whereas the bed has a packed only solid is 0.909, right. So, as we have been asked, this is the first one which we can say. We have been asked that what is the minimum height of the fluidized bed, right, minimum height of the fluidized bed that has become. Then it is the pressure drop at minimum fluidizing conditions, right. So, let us go and see what is the pressure drop. So, pressure drop so 1.515 was LMF was 1.515. So, roughly we can take 1.52 meter, right. So, now pressure drop under fluidized condition, this delta P MF can be written as L MF into 1 minus epsilon MF into rho P minus rho into G, right. Now, we have been given, if you remember in the previous sheet we had seen rho P was given, but rho of air is not given, right. So, since temperature is given, right, we can say rho of air, that is equals to P m by R T, right. So, P is 2 into 101,325 into m given 29 divided by 8314 into 30 degree centigrade means 273 plus 30, that means 303, right. So, 303, this becomes equals to, let us look into this, 2 into 101,325 into 29, right, is equal to this divided by 8314 divided by 303 is equal to 2.33. 2.3328. So, we can say roughly 2.33 kg per meter cube, right. So, once we know rho, then we can write that delta P is equals to LMF was 1.52, right, to 1 minus epsilon MF was 0.4 and rho S was 11, rho P was 1100 minus 2.33 into 9.81, right, or 82 in many cases we use, right. Therefore, this becomes equal to, let us see how much, 1.52 into 1 minus 0.4, right, is equal to this into 1100 minus 2.33, right, into 9.82. $9,830, right, 9830 is equal to 9830.55 Pascal, right. So, this means this is equals to 9.83 kilo Pascal, right. 9.83 kilo Pascal is delta P. Therefore, P inlet is so much. What is the P outlet? P outlet is delta P is equals to P inlet minus P outlet. So, P outlet is P inlet minus delta P. So, P outlet is P inlet minus delta P. P inlet is 2 into 101,325 or 101,325, okay, and this we can write 101.325 if we say kilopascal minus 9.83 is equal to 2 into 101.325 is equals to this minus 9.83 is equals to 192.82 kilopascal, right. So, we have found out what is the pressure drop and what is the minimum fluidization height, right. Third one, is the what we need to find out the velocity, right. So, for that velocity we can use that Ergun's equation, modified or new form of Ergun's equation as we have done earlier. This we can write from here that now since we know P2, right, on delta P of 9.82. So, delta P was 9.82 kilopascal, right, and P2 is 212 point so much Pascal. Delta P is 9.82 kilopascal. So, P1 was P inlet was 201,325, okay, minus 9.83. So, it is P in minus P out, okay. So, P out is P in minus delta P. Yes, P in is this minus that, 192.82. So, how come it is yeah, 2 into, how come it is delta P is P in minus P out, that is true. So, delta P it becomes P in minus P out, that is P out is P in minus delta P, yes. So, okay. Now, for that what we need, average P, P average is equals to P in plus P out divided by 2 is equals to P in was 2 into 101.325, right, plus 192.82 over 2, so much kilopascal. So, let us see how much it is, 192.82 plus 2 into 101.325. So, this is 2, this divided by 2, 197.735, 197.735. So much kilopascal is equal to 197.735, right, 197.735 Pascal, that is P average, right. So, if we use that modified Ergun's equation, then we can write that 1.75 by phi s cube into 1 minus epsilon mf square by epsilon mf cube n square, we said it is a quadratic equation, plus 150 divided by phi s cube into 1 minus epsilon mf square over epsilon mf cube nRE minus dp cube rho by mu square into rho p minus rho into g this is equals to 0, right. So, we can say A NRE square plus B NRE plus or minus C is equals to 0, right. Then comes what is A and what is B. So, A became equals to 1.75, phi s given was, if I see it properly, phi s 0.9, phi s given was 0.9, then 1 minus epsilon was 0.4 square divided by 0.4 square into NR is, oh, this is what, and this is equals to, let us see how much it is, 1.75 divided by 0.9 cube into 1 minus 0.4 square divided by 0.4 cube, not square, right. Phi s cube epsilon mf cube. So, it is 0.4 cube is equal to 13.503, 13.503 NRE square, right. B is 150 divided by phi s 0.9 cube into 1 minus epsilon mf is 0.4 square divided by 0.4 cube, right. So much NRE, and this is equals to 150 divided by 0.9 cube is equals to so much into 1 minus 0.4, 1 minus 0.4 square is equal to so much divided by 0.4 cube is equals to 1157.4, 1157.4 NRE, right, and C is equals to dP, particle size was given 0.127 millimeter, right. Particle size given was 0.127 millimeter. So, 0.127 millimeter into 10 to the power minus 3 whole cube, right. Rho in this case it was we found to be equal to rho average. Last we got average rho is P average. So, when we wrote P average, we can also write rho average is equals to P average to M by RT is equals to P average is 197,735 into 29 8314 into 303, right. So, rho average came out to be 197,735 197,735 into 29 divided by 8314 divided by 303, 2.27 kg per meter cube, right. So, from there we got that, oh my goodness, yes, C is this. So, that was into rho 2.27 divided by mu given was 1.8 10 to the power minus 5 mu square into rho p minus rho 1100 minus 2.27 into 9.81 is equals to 0. So, what we get? We get a quadratic, and from there we get the value of V, and V will come somewhere V average from there n-ary, right. If we define n-ary to be like this, VMF prime is n-ary into mu 1 minus epsilon mf by dp into rho into phi s. So, from there by calculation we get 5.5 10 to the power minus 3 meter per second, somewhere this value, right. So, if we try, because we are not having any more time constraint is there. So, if you try, hopefully we will get somewhere this value 5.5 10 to the minus 3 meter per second velocity, using, because from here this becomes n-ary square A plus B n-ary minus C is equals to 0. So, a quadratic equation, by solving it we get n-ary value, and from that n-ary value we can get the value of V using this relation. Okay. Thank you.